Welcome everyone to a new series, and the topic of this series is polynomial. So let's start the journey. In this video you will learn about what is polynomial, all kinds of polynomials including zero, linear, quadratic and cubic. Also at the end we will figure out the ways in order to find out which expressions are polynomial and which are not. So what do you mean by polynomial? Polynomial are expressions with one or more terms with a non-zero coefficient. Let's check with the help of example. If I'll say 2x is a polynomial that satisfies with one term. If I'll write 2x plus 3, it satisfies more terms. Hence 2x and 2x plus 3 both are polynomials. Even without this x or without this variable, you can say 3 is also a polynomial. Let's learn about what do you mean by terms and what do you mean by coefficient, as these two are new words. Let's do again with the help of example. If I'll say x square, 5x and 2, there are three terms which is connected by operation addition. So whenever numbers along with their variables are separated by operation addition or subtraction, then we will call it as terms. So here we have three terms. This is our first term, x square. This is my second term, 5x, and 2 is my third term. So terms are those which are separated by operation addition or subtraction. Is it clear? So in the polynomial, each expression in it is called a term. Now the next is coefficient. What do you mean by coefficient? In each term, there is a coefficient. So if I'll take this example again, x square coefficient is 1. X coefficient is 5 and 2 is known as your constant. Let's learn about the degree. What do you mean by degree? The highest power of the polynomial is called degree of the polynomial. For example, here we have four terms which is separated by addition operation. So we will check exponent of each term. In first term, x cube, 3 is the exponent. Hence 3 is the degree of this term, particular term. Similarly, y cube, 3 is the exponent. So 3 is the degree of y cube. Now check in 3x square y. Here there are two variables. X exponent is 2, y exponent is 1. In total 3. Similarly, in 3xy square, 1 is the exponent of x, 2 is the exponent of y. So in total we have 3, which is the degree of this particular term. Now we will check the whole expression, which is the highest degree in each of the term. In this particular example, all the terms are having 3 as a common degree. So highest one is also 3. Hence, our degree of this expression is 3. Next, we will learn about constant polynomial. As the name suggests, we are not dealing with any variable x, y, z, etc. We are just dealing with numbers, that is constant. 3, 6, 7, etc. So these are called constant polynomials. So next question is, what will be the degree of this constant polynomial? So for any non-zero constant polynomial, the degree is 0. Now why? If I'll write just 3, this is my constant polynomial. If I want to add x variable here, can I write it as x raised to the power 0? Why? As per the laws of exponent, anything raised to the power 0 is 1, which gives you 3 as a result. Hence, the highest exponent of this expression is 0. That is why the degree is 0. Next question arises, what do you mean by zero polynomial? So whenever the final result is coming out to be 0, then we call it as zero polynomial. If you see this example, we have different variables a, b, c, d, e, f, and if we replace all the variables with 0, then only our final result will come out to be 0. In that case, we will call that polynomial as zero polynomial. Now the very important question arises, what is the degree of this zero polynomial? Let's calculate with the help of this example only. See, if you take 0x cube raised to the power 5, what is the final answer? 0. If you take 0x raised to the power 4, then also you will get 0 as a result. Similarly, if you take 0 into x raised to the power 3, again the result as 0, and so on. You can take any example. With this 0, you will get 0 as a result. So we cannot decide the degree of the zero polynomial. That is why the degree of zero polynomial is not defined. Now the last concept of this video is how to check whether the given expression is a polynomial or not. So in order to check, we need to first check the exponent of each term. If each term having whole number as exponent, then that particular expression is a polynomial, otherwise it is not a polynomial. Check this example. In this particular example, x raised to the power minus 2. Hence, the exponent here is your integer. So we can say this is not a polynomial. Let's do some questions. A polynomial with 1 degree is called linear. Which one of the following is a polynomial? Now remember the concept. We will check the exponent and it should be whole number. If you check A part in this, x is coming in roots. Hence it is not a polynomial. Here x is in denominator, which means we will get negative exponent. If you check this, there is a possibility to solve further. This is absolutely correct, as 2 is whole number. If you further solve this using laws of exponent, this will become, denominator will become 1 by 2 as there is roots. When the bases are same, we will subtract the exponents. So let's subtract the exponent. 3 by 2 minus 1 by 2, which will give you 2 by 2, and this can be cancelled out. Hence you will get 3x as a result, which means x square also having 2 as a whole number, this 3x also having 1 as a whole number. Hence this is polynomial. Check D part here also. If you solve it further, it will become 2x raised to the power minus 2, which means this is integer. So this is not a polynomial. Right? Moving to root 3. Root 3 is a polynomial. We can say this is a constant, and constant polynomial degree is always 0. Now what is the degree here? This whole expression is connected with 3 operations, plus and minus separately. So we will check each term. In this, 5 is the degree of this first term, 2 is the degree of second term, 1 is the degree of third term, and 3, this is constant. Hence the degree is 0. So in total, Which is the highest degree? Highest is 5, hence 5 is our answer. Last question, what is the degree of zero polynomial? We cannot define the degree of zero polynomial, hence not defined.